Let us take a look at another interesting example. Here you have cotangent raised to power sine and x approaches to 0 from right-hand side. So we are looking at this piece of the graph. X approaches to 0 from right-hand side, and as you can see from the graph, it is equal to 1. But what is the calculus behind it? First of all, if you have these types of functions, like cotangent raised to power sine, or any other type of function of this form, it's better to take the ln of both sides. ln of y is equal to ln of cotangent to power sine x. Using the property of ln, when you have ln of u to the n, it is n times ln of u. So basically, you can take this sign and write it in front of ln. So we have ln of y equals to sine x times ln of cotangent of x. In the next step, we take the limit of both sides. The limit of ln of y as x approaches to 0 from right-hand side is equal to the limit of sine x times ln of cotangent x as x approaches to 0 from right-hand side. But it's not ready to use the L'Hopital's rule yet. Why is that? Because if you plug in 0, you get sine of 0. And when you plug in 0 here, you get ln of cotangent of x. Take a look at the graph of ln of cotangent of x. As x approaches to 0 from right-hand side, you see the graph goes to positive infinity. So you have 0 times infinity. We cannot apply L'Hopital's rule yet. We have to rewrite this expression so we can apply L'Hopital's rule. This is equal to the limit of ln of cotangent x divided by cosecant of x. Why? Because sine is basically 1 over cosecant. So wherever you see sine x, you're going to replace that by 1 over cosecant of x. Now, if you plug in 0, you get ln of cotangent of 0, which is infinity, divided by cosecant of x. As x goes to 0, you have infinity. So basically, you have infinity over infinity, and you can apply L'Hopital's rule. So when you apply L'Hopital's rule here, you have the derivative of ln of cotangent of x, and you have the derivative of cosecant of x. The derivative of ln, as you remember, if you have ln of u, it is equal to u prime over u. So we are taking the derivative of cotangent, which is negative cosecant squared, divided by u, which is cotangent itself. So u prime over u. Divide by the derivative of cosecant, which is negative cosecant times cotangent. In the next step, you're going to simplify this fraction here. When you simplify this fraction, you have cosecant squared and cosecant. You can cancel out one of these cosecant and you're left with cosecant on the numerator. You have cotangent multiplied by cotangent, so you get cotangent squared. Now you can take the limit. You have the limit of sine x divided by cosine squared of x. Why is that? Because cosecant is 1 over sine, and cotangent is cosine divided by sine, which is basically cosine squared divided by sine squared. And sine, they get canceled out, so you're left with sine over cosecant squared. When you take the limit as x goes to 0, you have 0 divided by 1, which is 0. In summary, when we have a function like this, cotangent x to power sine x, taking the ln of both sides, and then rewriting that as ln of cotangent of x over cosecant of x, we can apply L'Hopital's rule. It gives us the limit of negative cosecant squared divided by cotangent over the derivative of cosecant, which is negative cosecant, times cotangent. Then we simplify this to sine x over cosine squared of x, and then take the limit as x goes to 0 from right. It is 0 divided by 1, which is 0. But this is the limit of ln of y. The limit of y itself is e to power 0, which is 1.